If we have a function y equals 1 over x minus 3, we want to look at its graph. We first have to decide if we're going to make a table, for example, just to begin investigating the way the function behaves, and this is always a good way to do it. But we don't want to do this blindly. We want to make a table intelligently. We want to ask ourselves, where is the interesting behavior of this function going to occur? And hopefully, in looking at this function, we'll see that, the denominator is 0 if x equals 3, and something's going to happen there because we can't divide 1 by 0. So maybe we'd better center our table at the value x equals 3 and see what happens in the neighborhood of this point. So maybe we set up values 2, 1, 4, and 5 and do our calculations for y, and it's very easy to get these numbers. Okay, we see that the value, of course, is undefined when x equals 3 because we have division by 0. And these numbers, -1, -1/2, are simply going to continue decreasing. Okay, the next will be -1/3, -1/4, -1/5, approaching 0 through negative numbers. And these values, 1, 1/2, then 1/3, 1/4, 1/5, as you can see very easily, will approach 0 through positive values. So it seems that we're going to have horizontal asymptote on this side and on this side, and that horizontal asymptote is going to be the x-axis, the y equals 0 axis. Now between 2 and 3, what happens? We're going from a value of -1 to an undefined quantity. Well, undefined often but not always means it's going to become infinite in some way. Well, let's think about whether that happens and why it happens. Okay, as x approaches 3, x minus 3 is going to approach 0. That is, as x goes from 2 to 2.9 to 2.99, x minus 3 is going to go from 1 to 0.1 to 0.01 and so forth. This is going to get smaller and smaller. So we're going to be dividing 1 by smaller and smaller quantity as we go from x equals 2 to x equals 3. Between 2 and 3, that quantity is always going to be negative because x is going to be between 2 and 3. It's always going to be less than 3. So when we subtract 3, we always end up with at least a small negative number. So we're going to be dividing 1 by a smaller and smaller negative number. That negative number is going to go into 1 more and more times, and the result is going to be negative. And it's clear that there's no limit to how small this number can be, so there's no limit to how big the quotient can be, so we're going to approach negative infinity at this undefined point. Similarly, if we look from 4 to 3, if we approach 3 from values that move from 4 toward 3, okay, x approaches 3, 4, 3.1, 3.01, 3.001, whatever. X minus 3 is always going to be a positive number, but it's going to get smaller and smaller, as tiny as we like, so it's going to go into 1 as many times as we might wish. And in that case, we're going to approach plus infinity as we approach the undefined point from this side. The implications for the graph are pretty obvious. The x equals 3 line is going to be a vertical asymptote. As x approaches 3, the value of y gets larger and larger. As x moves away from 3 in the positive direction, we're going to get smaller and smaller, approaching 0 as an asymptote again. On the other side of the axis, we're going to approach negative values as we approach 3. And it's going to go toward negative infinity. It's going to look much like the reverse of this. As x goes through larger and larger negative values, we're going to approach the x-axis. And the x-axis will therefore be an asymptote.